Let's find the intercepts for the graph of the solution set of this equation. Y-intercept, we let x be 0 and solve for y. Well, if we do that, if we let x be 0, that'll be 0 cubed over 0 squared plus 2. Well, what's 0 cubed? That's 0, isn't it? And 0 squared is 0, 0 plus 2 is 2, and 0 over 2 is 0. So the y-intercept is going to be the point 0, 0. Well, that would also be an x-intercept, wouldn't it? Isn't the origin a point on both the x-axis and y-axis? Let's see if there's an additional x-intercept, or if that's the only one. So to find the x-intercept, remember we let y be 0 and solve for x. How would we solve this rational equation? Wouldn't we multiply both sides by x plus 2? Excuse me, x squared plus 2 is what we have there. Well, x squared plus 2 times 0 is still 0, and those cancel, giving us x cubed. And what's the only number we can cube that would give us 0? That would have to be 0, wouldn't it? So the only x-intercept was the one we already found, the origin. So the graph of this equation's solution set passes through the origin. Now, let's analyze it in terms of symmetry. To test for symmetry with respect to the y-axis, I'm going to replace x with minus x. And see if I can get back to the original equation. Well, the square of minus x is the same as the square of x, isn't it? But what's the cube of minus x? What's the cube of negative 2? How does it relate to the cube of positive 2? Isn't it the opposite of the cube of positive 2? So the cube of negative x is the opposite of the cube of x. Because the cube of negative 2 is negative 8, the cube of positive 2 is positive 8. So I can't get back to the original equation. So this equation's graph does not exhibit symmetry with respect to the y-axis. I couldn't get back to the original equation when I replaced x with minus x. Let's try testing for symmetry with respect to the x-axis. To do that, we replace y with minus y. And if I wanted to get back to at least having positive y, one approach would be to multiply both sides by negative 1, wouldn't it? So that's going to get me back to y, but that's going to give me here negative x cubed over x squared plus 2, which is not the original equation. So the graph of this equation would not exhibit symmetry with respect to the x-axis. Let's try testing for symmetry with respect to the origin. When we test for symmetry with respect to the origin, we replace y with minus y, and we also replace x with minus x. And see if we can get back to the original equation. Well, we already saw what the cube of minus x is equal to. That's equal to minus the cube of x. And the cube of x squared, excuse me, the square of negative x is the same as the square of x. But now if I multiply both sides by negative 1, I get y equals x cubed over x squared plus 2, which is the exact equation we started with. So the graph of this equation's solution set, whatever it looks like, it passes through the origin and exhibits symmetry with respect to the origin. It would be interesting to find some solutions and plot them and see if we could get some idea of what that graph looked like. And I'll leave that for you if you have an interest in trying to visually picture the graph's solution set.